Okay, so hello and welcome to this talk about identity access management, or what I learned from a project where we took the identity services from on-prem and in-house to the cloud. My name's Danni, Youziel, by the way. So before I start, let me tell you a bit about myself. So I'm a software developer, and I work with cloud technologies. Before that, I did a stint, funnily enough, in quantum computation, but I thought that would never actually happen before I died. That was probably a bad career move. And then after that, became a software developer, and I also love to travel. And it's funny enough that when I was traveling, that I actually became interested in security and identity. I was on a trip in China, and I saw a woman in front of me pay for coffee with her face. And the first thought was that it was amazing, and then the second thought was, what would happen if someone hacked her face? So coming back to the UK, started off small, got into securing endpoints, then kind of escalated to hacking a few friends, using the social toolkit, and eventually into biometrics. And this project that I'm about to talk about is a result of that interest in security. So what I'll do is first I'll give you the basics and the building blocks of identity access management. Then I'll go through the project that we had, the project in question. And after doing a discovery, an inception, and considering the agile environment we were working at, how we came to what we wanted, how we wanted to improve the usability and admin of the identity service, and then finally how we got there. So what is identity access management? First of all, I apologize for anyone online because I didn't put this as a poll, but can any of you tell me what you think identity access management is? You can also put questions in Rocket. Okay, I'll tell you. Oh, is that a hand?
It's a service in AWS, isn't it?
There is a service in AWS that offers identity access management, but it goes a bit beyond that. But cool, thank you. So first of all, it comes in different parts. We've got the IM part, or the identity management bit, and that's basically you being able to prove who you are. And that's usually done with usernames and passwords, and I'm just going to call those credentials from now on. And then the second part is the the access management part, and that's also known as authorization. And that is a set of roles or rights you will have to be able to access resources within your organization, which is also based on the role you have within your organization. And then because you're going to have so many different people wanting to access loads of different things on different levels, you're going to need a database or repository or directory, whatever you want to call it, to store these users and their profiles. And then finally, you're going to need someone to manage that repository, because you're not only just going to have the people working for you at any given time, but you're going to have joiners, movers, leavers, and those really annoying people that have not realized you've got password management and always forget their password. But if you get all of that in place, it gives you a range of capabilities. So you have, or you will hopefully get things like zero access management. You'll be able to audit and see exactly who has seen what. You will be able to set things up like multi-factor authentication, which I think we probably all use now at work, where you enter your credentials and then a code is sent to your phone. And you'll also be able to do things like single sign-on. So rather than having to remember a different set of credentials from everything to Confluence to email to Jira, you could just have one set of credentials that will give you access to all of that. So what does that actually look like? Well, let's say you have this internal web application at work, and you enter your credentials, and let's say you want to get some financial data. Hopefully, that will all go successfully well. But what's going on underneath all of that? Well, when the developers made this application, they would have had it or done it with business logic in mind. Basically being able to process all your actions to get data, finances, users, all of that stuff. But then they would have known that they would have wanted certain people to access some things, certain people to access other things, and some people they would want to give no access whatsoever. So they'd need a database of people, and they would need the user to authenticate into that database. And then once they've done that, they need to get the rights and roles associated to that user to let them go on whatever logic they want. The only thing is you're a developer of an application for your business. You don't want to be splitting your time between business logic and identity logic. And you also don't want to take the backlash when any of that security stuff goes wrong. And also, if you're going to scale this up, you are going to end up with a load of duplication and replication for all the different internal applications you have. So instead, what you can do is you can abstract that identity logic out into an identity provider or an IDP. And what will happen then is, rather than have logic inside your application to actually authenticate and assign rights and roles, all of that will happen within the IDP. The user will authenticate to the IDP, the user's rights and roles will be in the IDP, and there will be trust between your IDP and your web application. And that can be done with certificates or client IDs and keys. And so once the user's authenticated successfully, they'll get some sort of token back to say, we trust that person. And then that user, in any request, will forward that token and get the correct access within the app. And so in the app, rather than being responsible for authentication and authorization, it just verifies all of that. And if you really want to be efficient, you also want to delegate all the user database stuff out and give that to the IT or HR people. So then HR or IT are responsible for the user database. That provisions users into your identity provider. There's trust between your identity provider and your web application, so your developers just concentrate on the business logic. So I said I like travel, so here's a travel analogy. If you go to the airport, hopefully you're going to take your passport with you, and then you hand that passport over to someone at check-in, and then you stand there smiling while they look at you and you do all the awkward question stuff. But eventually they will give you your boarding pass to be able to get on your flight. And that boarding pass not only gets you onto your flight, but it also gets you into things like the lounge and also duty-free. Your boarding pass is like a token, and it basically is establishing that trust whenever you go to any of those additional places. So you have your passport scanned and checked once, and then you hand over this token every time you want access to anything else. So in terms of web applications and internal web applications, how is that important and why? Well, in today's workforce, you've got a lot of hybrid setups. You'll have people employed directly, you'll have consultants, you'll also have a load of third-party employees as well. And you need to be able to manage all of that. And having a setup with good workforce IAM, something that follows those building blocks I showed before, you can be able to have good governance, security, and oversight. And what that basically means for your business is that you can reduce risk and you can reduce cost. So, any questions so far? Also, please put questions in the Rocket app if you're streaming. But yeah, any questions so far? Good. This is good. Cool. Okay, so what application was I actually talking about, or the one that I worked on? So the organization in question had two applications that were of particular interest. One was a web application that all of the users in the company needed to work on. And I'm going to call that Japan because the UK did not seem too politically correct. And then we had another set of internal business applications, and those were things like Confluence, Jira, and email and things like that. And only employees that were hired directly by the company needed to access that. And I'm going to call that setup Europe for brevity's sake. So we had a HR department that managed this massive meta database of everyone. And then they would be responsible for saying this set of users go into the Japan repository, and this set of users go into Europe repository. And then from those separate individual repositories, those users would be provisioned into the IDP and have access to the applications. So Europe's application, or Europe's identity provider, was Azure AD. That was cloud-based, and it enabled things like multi-factor authentication and single sign-on, which I'll talk about in more detail later on. We also had Japan, and its identity provider was LDAP, and it had an Active Directory. And LDAP is a protocol or a way of querying the database in the most simplistic terms. And that was in-house. But it didn't have anything great. It just authenticated. No SSO, no MFA. And LDAP is also notoriously difficult to adapt once it's been put in place. But they did issue tokens, and they were trusted, and so users could access what they wanted. In the I did not mean to do that, what have I just... So, in the case of Japan, the identity provider in that situation issued an opaque string, which basically looked like that. So when the user would sign in, they'd get their opaque string, and then every time they did a request, that opaque string would be sent with the request, and then that would need to be sent back to the identity provider to get the rights and roles for that user, and so the user could go on with what they wanted to do. It does seem like a lot of going back and forth, but it does mean that the user's details, like their name, rights, roles, and stuff like that, aren't exposed, and so like malicious attacks are limited, hopefully. We then had the situation with Europe, or with the Azure AD IDP. This issued a string, but the string was what we call a JSON Web Token. And that could be decrypted, and what you would end up with is a header, a payload, and a signature. The header and the signature, think about that like the front of your passport and any hologram over your passport picture. Those combined can be used to say that the passport or the token has not been tampered with. And then you'd get the payload, and that information would contain the rights, roles, and a series of user information. That basically meant processes were a bit faster because you could, that again was sent with the header or any request that was sent. And so once someone logs in, they get their JWT, make a request, the application will decrypt the JWT, have access to the information, and everything goes as planned. Two things about that though, the JWT can be decrypted by anything. You can literally go on jwt.io and decrypt a JWT. But there is a process known as OAuth 2, or in OAuth 2, known as the Authorization Grant Flow, which means although you have a web app, as long as you've got a trusted backend server, you could use a combination of a token. Once that has been authenticated, then the JWT can be used to get, or the JWT will be issued, and you can get the information that way. So the other thing we spoke about, or I spoke about with Workforce IAM, is the whole idea of making it easier for the admin and also for the users. So I said before, we had Europe and we had Japan. The IDP for Europe allows users to use all the applications in Europe, and the IDP for Japan allows users to use the Japan application. And those form what we call security realms. Only thing is that if you are in Europe, you cannot use anything in Japan. And if you're in Japan, you cannot use anything in Europe. Which meant we had duplication, because as I said before, everyone in the organization had to access Japan, but only those hired directly by the organization could have access to Europe. But just like we had trust before with our IDPs and our web applications, what if we could form trust between our security realms? At the moment, there's no trust at all. But if we could establish trust using something like client IDs, secrets, certificates, what that would mean for us is our users in Europe would be validated sign-in into Europe. And then they could then have access to Japan's applications. What it also means is that the admin in Europe, if they take away the access in Europe, that person automatically loses access in Japan, and Japan never needs to know about it. So, in summary, we figured we needed an identity as a service, and I say identity as a service because we were not going to do this ourselves. Why do that if you can get it out of the box? So we were going to use an identity as a service, and we needed it for our Japan client, and it needed to be able or capable of authorization grant flow. And then we also needed an identity as a service that was compatible for federation with Azure AD. What would you have chosen if any of you have worked with identity as a service providers?
This.
Pardon?
This. Azure AD.
Azure AD? Anyone else?
Zero.
Yeah, we didn't. We went for AWS Cognito. There were reasons, justified reasons, which I will not go into now. But yes, we did choose Azure AD. AWS Cognito. And the reason for that is because it provided loads of good user capabilities, good admin capabilities. It also had everything kind of wrapped up in terms of its IDP. So it had this thing called the user pool, where the database and the IDP were all wrapped up into one, which we thought was quite convenient. And with AWS, it's a case of the costing. It's always the costing. The costing seemed a lot more transparent than Auth0 as well. So what does the flow look like inside an AWS Cognito authorization grant flow? So again, we used everything that was out of the box. So when somebody came to our web application, we would redirect them to a hosted UI. The hosted UI was good or great because it took away a lot of the coding involved with linking our app to Cognito, and it also took a lot of the heavy lifting in terms of things like token storage away from us. So once they authenticated via the hosted UI, then AWS would send a code back to the web application, and then when the user wanted to make an action or do an action, that would be sent to a trusted backend server. That code would go back to Cognito. You then get the tokens required and be able to continue. So that seemed quite usable at first and quite straightforward, and we really, really liked it. And what we also really liked is in the development process, all we had to do was basically tick boxes on this user pool UI to enable things like MFA and SSO and so on and so on. And being in the whole agile work environment, we decided do the bike before the car. So first thing we tried to set up was multi-factor authentication, and then do SSO. The problem we discovered with that was, just as it was a benefit that the user pool and IDP were tied together, it also turned out to not be such a benefit. The reason for that is because the user pools didn't have any built-in export data function. We trusted AWS, so we thought, yeah, if AWS goes down or if something goes down, they'll still have the user's information and passwords and all of that stuff. But what happens if one of your developers accidentally deletes your database? That is a problem. And that might sound like a fireable offense, but the thing you have to remember is the user pool, in order to set up the things you want, like MFA, you could only do that when you set up the user pool. If you wanted to add anything else, you have to delete your user pool instance and start all over again. So it's not as difficult as that sounds. And so that presents a problem, and that problem needed some workarounds. The first workaround came from AWS, of course, and what they said was you could use a set of lambdas, a set of discrete functions triggered by events. So every time you added or removed users from the database, or user pool, sorry, that would change the metadata. And the change in the metadata could be used as a way to trigger lambdas to export your data elsewhere, to another S3 bucket, or sorry, to an S3 bucket, to another user pool, or DynamoDB. And what I just described is, in simplification, the workflow, export workflow step function within AWS. The only thing Amazon adds is that if you do want to use that option, multi-factor authentication, if you set that up, is not supported. And it's also very dependent on your monthly active users. So given this is a log-in, log-out kind of area, your costs could rise significantly. However, you could always just abuse the work done by the NPM collaborator, because basically what you're doing is a cron job. So he wrote a library, and all you need to do is input some very, very simple information, such as your region and the file name you want to export your data to. And you can use that instead to export your user data into any storage service. It doesn't need to be AWS. So that was the user pool experience. Next, federation. So federation, we did that with Azure AD. And this is what it looked like in terms of the flow. So a user would be directed to a hosted UI, and then they would be directed to authenticate to Azure AD. Azure AD would send an auth code back to AWS Cognito. AWS Cognito would be responsible for retrieving the tokens, and then it would send the access tokens or ID tokens, the JSON Web Tokens, back to the web application. The beauty of this was that our web application didn't need to have any knowledge of Azure AD or any other identity providers we would give it. All it would need to know was how to handle the tokens it receives from AWS Cognito. Let's talk about those tokens, actually. So basically the web app was handling JSON Web Tokens. And the JSON Web Tokens, once they're sent, they're sent. This is what they look like inside. So you've got the header and you've got the signature. But that's not really the part we're interested in. It's the payload that was part of interest. You get an issue that time and you get an expiry time. And that tells you how long it's valid for. So as long as that token is valid, that user's credentials are valid. This might not seem like a big issue, but when you're talking about banking, it can become a very big issue. If you've got a long expiry time, that basically means if you want to revoke any of your users, there's a very long latency between you revoking them and them actually being kicked out of the system. So instead, what you want is you want to have as short as possible expiry time, usually 5 to 15 minutes. And then on top of that, you can have refresh tokens. And the refresh tokens are sent with every subsequent request, but they can also be revoked. They don't necessarily have to be accepted. So in this, it's not really a new flow, to be honest, but in this scenario, we say they authenticate, they get their JWT, do their actions, but it's only valid for 15 minutes. If they're still active after 15 minutes, they then send the refresh token with the requests. Those refresh tokens can be accepted or they can be rejected. If somebody has revoked your access, they will obviously be rejected and you'll be kicked out. And if they haven't, then you just carry on as normal. And that seems like a pretty good solution, unless you're AWS Cognito. They decided to have a minimum expiry time of 1 hour on their JWTs, which basically means when you sign out, you're not signed out for up to an hour. That is a very big problem. Of course, there are workarounds. The easiest workaround for this one would be for AWS to not set a minimum time of 1 hour on its JWTs. But that hasn't happened yet. So what you would need to do instead is create an additional database of revoked JWTs or changed access. And in your flow, this would need to be checked every time somebody changed a wanted access. What this also means, though, is you've added a bit more chattiness to your service, and your JWT now has state. So I forgot to mention the web application was REST, so it needed to be stateless, but that doesn't really matter now. Anyway, so yeah, your JWT has state. So that is not the best solution. So, talked about what IAM is and what good IAM is. Spoke about what we had and what we wanted. What we wanted was to break down the silos in our identity management. And the best way to do that was by federation. What we also wanted to do was make the system a bit more, I wouldn't say flexible, but faster and easier. And we believed that getting rid of the opaque strings, which meant a lot more conversation between services, and replacing them with authorization grant flow was the best choice. And it worked, and it is working. And AWS Cognito does have some benefits, but it feels like it's still, I wouldn't say in the baby phases, but there are some still workarounds to be done. Any questions on that? Yes?
Do you feel that part of the problem is the mixture of authentication with authorization?
Could you elaborate, please?
So JWTs, I am me, but what should I be allowed to do?
Yeah, so I guess so before the whole thing with the JWTs, it was all about the opaque tokens. And the opaque tokens were like, you get that when you when you say you are what you've done, and then that has to go back and forth to get the what you can do, what you want to do. So the JWTs combined those to make systems less chatty, but have also sprung up its own problem. Because the thing is effectively now, we have gone back to the whole, not necessarily the opaque string situation, but we've gone back to the fact we now have to check an additional database to actually check if the JWTs have been revoked or not, which is...
Should we have a conversation after about open policy agent? I think this might...
Okay, cool. Sure. I kind of got through that talk a lot faster than I thought I would. Sorry. Does anyone have any other questions? I can't actually see because the light's really bright, so...
Okay, no problem. What was the biggest challenge on the project of everything you walked through? What was the biggest challenge?
Definitely, I would say it was the user pools, because with the user pools, it was about what's the best way to keep all of that information safe without losing it by accident. And that took a lot of discussion, because we had to get like the external security people involved as well, because it was a case of we could do the AWS architecture, but even that wasn't ideal, because if we did their architecture, but we wanted MFA, it wasn't compatible. And it was also going to cost a lot of money, which you always have to deal with. So yeah, it was definitely the user pool situation, which is also very, it was unexpected. Yep.
Would you take a different approach now?
Yes.
And what would you...
I probably would have gone with all 0, to be honest. At this stage, yeah, I would have gone with all 0. Cool. Yeah. Anyone else? Sweet, I guess you get to end early then. Thank you very much for coming to my talk, and enjoy the rest of your day.